Hi, I'm Curt Frye. In this movie and the next, I'd like to go into some detail about cluster analysis and how to implement it in Microsoft Excel. So the first question you might ask is, what is clustering? It is a technique to identify groups of related data points. And there are many methods, but I will use the centroid method. And it is broken down as follows. First, you guess how many clusters you need, and those are groups of data points. For example, you might have customers, and just by looking at your data, think you might need 3 or 4 groups to adequately describe them. You generate that many points to serve as centroids, and then you identify the centroid closest to each data point. So a centroid is essentially a central data point, and it will be moved around based on the objects around it and that are associated with it. So you move the centroid to the middle of its points and you repeat until you stop making progress. We'll do it by hand so that we can get some experience with the process and provide insight for when you do the work in Python or R or using another dedicated package. But it's important that you understand what's going on behind the scenes. A bit more information about how clustering works can be seen here with a collection of data points. And this is a fairly simple example. You can see that there's a group on the left and a group on the right. If we add centroids to the middle, then we can move them around to identify the middle of the two groups. So to calculate the centroid distance, we find the points that are closest and then move the centroid to the middle of that group. The first thing we need to do is calculate the distance from each point to a centroid. And we'll use the Euclidean distance, which uses the Pythagorean Theorem. So let's look at these 2 points specifically in relation to the centroids in orange. The Pythagorean Theorem says that a squared plus b squared equals c squared. So in a right triangle, you have one side which is a squared, a second which is b squared, and then you have the hypotenuse of c squared. And c squared here is the Euclidean distance from the blue point to the centroid in orange. And the same thing for the other point. You have one side of the right triangle, the second side of the right triangle, and the third is the hypotenuse, and that is the Euclidean distance. Once you calculate those distances, you can move the centroid to the center of the points that are closest to it. So we have our 2 centroids and the points around them. And so the centroid on the right would move to the right to what's approximately the middle of those points, and the same thing for the centroid on the left. And your repeat is required. The nature of this technique is that different starting points might mean that you get different clusters. And also, some starting centroids don't give valid solutions, so it's important that you observe the results and run multiple times. You'll also find that different numbers of clusters will offer multiple perspectives on the data you are looking at. And of course, your domain knowledge and common sense are your friends. You need to be able to let go of your assumptions, but knowing something about your data and how the measures that you have created describe it will go a long way toward helping you perform meaningful analysis. With this introduction in mind, I'll switch over to a Microsoft Excel workbook that I've already created, and this is one that we will build as the movie goes along. With that introduction in place, we can work through the Excel workbook that you see in front of you. And I'm not providing this because we will build it up as the movie goes along. And the process of building it is extremely useful. I'll start with the XY scatter plot that I have here, the centroid analysis example chart. And here I have 3 distinct areas of data or clusters, here in the top right, here in the middle, and here in the bottom left. And I also have 3 centroids that are marked in orange. So there's 1, there's 2, and there is 3. You can see the points of the centroids here in this table. And then also, over on the right, you can see the x and y coordinates for each of the blue points. And those are the whole numbers here in the x-axis and y-axis columns. Beside that, in columns C through E, which is distance to centroid 1, centroid 2, and centroid 3, we have calculations that do the Pythagorean theorem to discover the shortest distance. Or actually, this calculates the distance to each of the centroids. And then in column F under centroid, we determine which of them is the shortest. And the shortest distance is the centroid that we assign to a particular point. The other elements that you see here help with the calculations, so I won't go into detail here. But instead, what I'll do is click the Update Centroids command button here, and that will run a macro that will update the position of the centroids in the chart. So I'll click Update Centroids, and you can see that they have moved a bit. We still don't have a good centroid for the central group here, though. So I'll click again. Click again. We're getting better. Click again. And click one more time. And there we go. And I can tell that we're done because the values here in my centroid table are the same as the centroid updates. And in fact, if I click Update Centroids again, we get exactly the same values back. And that tells me that we have found a very good solution.